G'day, and welcome to How to Put DevOps into Action for Your Database. I'm Hamish Watson. Look, PASS has so much to offer, and there's so many things that you can explore and take advantage of. Please fill in the session evaluation form. It's important to us, and it's very important to me. And if you do it before Friday, November 20th at 5 p.m. Eastern Standard Time, you can even win stuff. G'day, I'm Hamish Watson. I'm presenting to you all the way from Christchurch, New Zealand. I own my own company, which means that I can make up ridiculous job titles for myself. I'm a Microsoft Data Platform MVP, and I'm a friend of Redgate. They do fantastic DevOps tools for databases. I'm a director at large on the PASS board. Community is really important to me. And if you haven't already voted, please vote in the elections. I used to speak all around the world. Nowadays, I still speak around the world, just virtually, from my office here in Christchurch. DevOps, Azure, and data are both a personal passion for me, as well as drivers for my company. And I love to help people get on board, to not only understand their data, but to make stuff go. All through my career, I've come to the understanding that I'm a technologist who understands business value. And when I talk about DevOps, I talk about value, the value that we're delivering, as opposed to, the queries and the indexes that we tune and think are great. Clients want value. Alrighty, let's get into it. What's the agenda? Well, as part of this learning pathway, you pretty much will know what DevOps is all about. And when I was thinking about this session, I wanted to kind of pull things together and think, what are the top 3 things you need to do? Well, in fact, it's more, what are the top 3 things that people fail at? And in the demo today, majority of the session is going to be demo. I'm going to demo 2 of them. So what are the 3 things? They are how you manage your work has to change. And part of that is understanding that our career has, the way we manage our work has got to change. Now, Gene Kim came up with something called the 3 ways of DevOps. The first way is flow, how our work travels through our process, value stream, whatever you want to call it. Enabling flow means work in our system moves quickly. And there's some great analogies around, using a factory floor about where components move from here to there, come together, and, our work items move through the system quickly. However, when people embark on DevOps, they want to play with Kubernetes, they want to play with containers, they want to introduce the database into the DevOps pipeline. Whereas in fact, we need to focus on how our work flows. Because if we cannot see our work, if we have hidden work, we can't manage it. And so part of this is around embracing Kanban boards. That agile thing. Don't worry, this is not a session on agile. But I want you to think about how you manage your work, because your work needs to be tied to that delivery of business value. We use our tools, we create a process, and we automate a DevOps pipeline to reliably deliver business value. And so we need to improve the quality of our tasks and our work items, and tying it again to the requirements of why we're making these changes to our database, to our application. And we need to improve the sign-off process, right? So if we're waiting for weeks for sign-off, something's very wrong. We want sign-off immediately. We need feedback immediately, not after months. And we need to make our deployments automatic. And here we're not actually talking about deploying to production, but rather to the development environment. And basically, anytime we have manual activity, we want to automate it where possible. We also want to collaborate as part of our workflow. We need to join the development morning stand-up. We need to know what's going on. And if we do that, if we collaborate with developers, it means that we actually find out what they're doing. We can help and go into things like sprint planning or planning sessions, whatever works for you, so that we find out right at the offset and we can say, hey, look, you actually need to do X, Y, Z, as opposed to when it's deployed in production by the development teams and then we're called in because it's on fire. That's the wrong kind of flow. The next one is feedback. It's great when work moves fast, but if that work is of bad quality and has to constantly move back to earlier steps in the process, you know, a bug's discovered, the requirement was misunderstood. This is not great. And when something goes wrong, you need to know as soon as possible. We want fast, tight feedback loops in our system. And this is very much around quality control through our process, supported by automation. So if we're writing unit tests, we're going to feed those unit tests into our automated pipeline. And automated testing should be part of our development. And we have to build a suite of automated tests to know if things are broken by our new development. And we need different levels of testing added right across our deployment pipeline. The speed of the feedback is of essence. If something can be shown within 5 minutes, it's better than spending hours. And so I'm talking about having integration testing, functional testing, I don't know, maybe even performance testing. And if that's a new concept to you, please look into performance testing. You need it. Part of this is having good code review and branching processes. And in the demo, which is the majority of this session, we're going to look at how to create a pull request and what's required before we merge the branch that we're working on into our main branch. The last way that Jin Kim talked about, and this has been around since 2012, experimentation. However, this is the only area I disagree with Gene. I feel it should be called failure, because then you have 3 Fs, right? Flow, feedback, failure. Anyway, so my definition of failure is always an option. Failure should be something that we have, but where we have it is the appropriate part of this. I want to build a platform that means that I can try things out and fail either on my, my laptop or in a build environment. And if it works, brilliant, we go on. If it doesn't, we throw it away. And this means that we can continually experiment. We can take small risks and we can learn from the failure. The other thing, we can't treat DevOps as a one-off effort and hope for it just to last forever. I've done DevOps for my database. I'm done here. Heck no. There will always be new challenges. There will always be new people. There will always be new technology, and there will always be new project reality. So we need to be able to experiment and learn all the way through. So what does this look like? Now, if you've ever seen me present, you know this animation. The reason why I've been using this animation for 5 odd years when I've been presenting at past is because it really illustrates what we want to do as part of our DevOps pipeline, deployment pipeline, whatever you want to call it. So here we have continuous integration. Our developers and DBAs have written unit tests. They've merged it into source control. It's kicked off a build. We do some build tests. We deploy it to our build system, which might be a container running on Kubernetes, whatever, and we get immediate feedback. And if it breaks, we stop, we remediate. But if it works, we're then going to deploy it out. The key thing here, these are prod-like systems. They are systems that have the same structure, schema, set up as production, and they're built from source control. That's a key thing. And it means that I can have these small little environments all the way through my pipeline that will show iteratively if things work. And if they don't, we just come back. We fix it and then deploy it out. The key thing here is we're going to do continuous monitoring all the way through, right? Because that's a way that we can scrutinize our changes. Did it work? Yes, no. How we make things has to change. Here is a typical day in my life. I'm across a whole heap of different languages that I'm writing code in. And at the end of the day, I even write JSON because here I want to handle the monitoring of my Azure SQL database that I've provisioned using Terraform up in Azure. The key thing here is data, because all the way through where I've written all these things, it still relates to data. You know, I might be doing machine learning model using Python, but at the end of the day, I need to know the status of my system, and this here is an alert if something goes wrong. It would be hard to go through every single language that I think you need to at least look at. And you don't have to do all of these. Pick one. You know, if you're doing on-premises stuff or stuff in the cloud, you should learn PowerShell. That's fundamental, I think, these days. I hosted a panel discussion a couple of days ago at Past Summit on, you know, PowerShell and why it's so important. DBA tools. You don't even have to learn PowerShell to use DBA tools. That's the magic of it. But go and have a look. It will make your life brilliant. Desired state configuration. This is a module within PowerShell. It's a way of ensuring that what you build is the state of what you want to do. And all these languages here are around infrastructure as code or configure as well as configuration as code. Terraform and Bash, they're my go-to. Why? Because Terraform is a way of provisioning resources, and then I can use Bash as a method to configure them, as well as Bash is what I generally use in Azure, because it hasn't changed. There have been changes with Azure PowerShell. And yeah, early on in my career, I learned how to script, and working with Azure using Bash is, yeah, really easy and fun. And you know what? If you want to use Azure Resource Manager templates, you're more than welcome to. I do if I have to. I do prefer to do things other ways, but at the end of the day, you know, writing in JSON to provision something, I'm happy to use ARM if I have to. You are more than a DBA. The landscape has shifted in the past few years. We are not just administrating databases, we are engineering a platform. We need to ensure reliability of that platform. And we want to collaborate with other teams to build that platform. Virtualization, infrastructure as code, containers, serverless computing, cloud and distributed systems are now commonplace. And we need to embrace aspects of these and bring our database into these paradigms. We need to break down barriers. We need to treat everything as code and automation of nearly all the things. And of course, monitoring and operational visibility is key to help us do data-driven decisions. So what does a team look like? How do we do this collaboration thing? Well, we don't want to be this. We don't want to be a silo. We need to assemble a cross-functional team. We need key representatives within this team. And this team may be an informal team, but it has a common goal of engineering a platform. And we'll have key representatives from, I don't know, development, DBAs, database developers, testers, architects, infrastructure. The common goal is quite simple. We need to work better and work faster, but we don't want to create a new silo of the DevOps team. We need to collaborate. We need to break down the informal silos that exist. So that means we've got to be mates. That's a Kiwi term for being friends. We've got to get to know each other. Make a conscious effort to find out how we fit in towards the common goal of delivering value in an automated and reliable fashion. So part of this is getting a good communication channel. You know, you might use Slack, Teams, whatever. And celebrate each other's achievements. You know, invite and go along to sprint reviews. Go along to those stand-up meetings. Go along to the planning sessions. And if someone says to you, you shouldn't, it's them, not you, that has the problem. And we want to foster knowledge sharing and a blame-free culture. Blame-free culture means that we're going to fail, but we're going to fail appropriately. We're going to fail lots in continuous integration, and we're going to celebrate lots and be deployed to production. Sharing knowledge is key. When teams learn from each other, they understand each other better. And that might be that you show developers the effect of not having an index on a particular table, or how to tune their queries better. You know, don't write a user-defined function. SQL Server Engine kind of hates them. This is a better way of doing it. So we've got to work together and just be friends. Alrighty, I'm going to do a demo now. We're going to provision a database. We're going to fold it into a DevOps pipeline. And we're going to use Terraform. So at the moment, the development team, the application developers, they have been using Terraform. They're spinning up some resources in Azure. They deploy their ASP.NET package out, and they're using some really cool secure mechanisms, because with Terraform, we have to save our state, right? And so sometimes we might save that locally, whereas in fact, that doesn't work when we're distributed. So we're going to spin up some storage in Azure. We're going to store our keys there. We're going to call them later. And at the end of the day, we're going to deploy a website. Alrighty. So what I'm going to do now is kick off with the demo. Now, two things. Because I live in New Zealand, my internet's not the greatest, so I'm going to actually turn off my video, but you'll still hear me talk. Okay, so here we are. I've got a VM, and we're going to have a look at this project in Azure DevOps. I make use of the cloud a lot because it's a great place for me to, you know, try things out, spin stuff up, tear it down, whatever. Now, this particular project is where we have the files for spinning up an app service. So we have a directory here where development team have been using Terraform to spin up an app service, right? So I've spun up an app service plan and spun up a particular app service. So we want to join the party and get on this train of good stuff. So what they also have is a pipeline that has a few things in it. So this is a .NET Core app. So they do a whole heap of, you know, development stuff that I don't really care about too much. And, you know, they copy their Terraform files to an artifact along with publishing, you know, their application code, whatever that is. And the real good stuff is in the release. And so what they have there is a release process that does a couple of things. And we really want to get on board with some of the good stuff that they're doing. And part of that is, you'll notice here we have an Azure CLI step. And basically what we're doing here is we, by default, you know, Terraform stores the state of what we're spinning up locally in a file called terraform.tf state, right? So that's cool. It's just something that Terraform does. But we need to store it somewhere that isn't local, you know. And so what we want to do is we're going to use remote state where we're going to actually have a data store where we're going to store some of that Terraform stuff. And so we're using Azure CLI task here to create an Azure storage account and a storage container to store our Terraform state. So again, this is why I say to people, we need to learn more languages than just T-SQL if we're going to become that data engineer. I like Azure CLI. The reason why I like it is because it generally has stayed consistent. I have found Azure PowerShell over time. I've had to go from a couple of versions of it, and yeah, so generally I will use Azure CLI where I can. And so again, that means that we need to learn a little bit of Bash, enough Bash that we can, you know, look at directories, store files, and call things in Azure. And the great part of this demo is that I've also included some Azure PowerShell, right? And so what we're doing here is we need a storage account access key for the Terraform backend that we've created. And so basically we're just using Azure PowerShell task here to get the access key of the storage account we created here. All good stuff. Now, I make use of variables, and if we go back to our repo in the Terraform code here, and by the way, this is a particular type of language called HashiCorp configuration language. It's kind of like YAML, and you'll notice in here we have some variables that have, you know, underscores in front of them, right? So our app service plan, our storage account, what have you. And so one of the really cool things is we can replace tokens in our Terraform file. And if we come down to advanced, we're looking for things with a prefix and suffix. And then what we do is we come into variables and we replace those with these settings here. It's a really good way of easily having things in source control. We don't want to have the, you know, our administrator password or even our administrator name in source control. We can have that in our variables here and then just replace them as we're building things. And so what we now have to do is ensure that we're actually going to use Terraform on our agent that's running everything for us. And so we make sure that we're installing a particular version. We now come into, excuse me, the meat or the main part of Terraform. And what we're doing is doing a Terraform initialization. And basically, this is where we're going to initialize our working directory. And so we're, again, feeding in our variables. You'll notice one here and our storage account here. And after we've initialized, we then run our plan. Now, this is really important because we need to produce a plan for changing our resources, right? To make sure that one, the Terraform code we have is valid. And we're then going to create the execution plan of what we're creating. And so what Terraform does, it determines what actions are necessary to achieve the desired state, because this is all about the state of our resources specified in, you know, the configuration file, which for us is this web app.terraform file. All good. So after the plan has run and is all happy, we then will do an apply, which is basically the command to deploy the resources. Often it will, if I was running this locally, it would ask me to approve, but I've actually told it to auto approve because, you know, we're automated deployment. We just want things to go and don't actually want to be prompted or anything. Alrighty, last step. So these steps here are all about the creation of our resource. We have to deploy the resource, right? So we've created the app service. Well, we need some of that code. And so this is where we actually deploy the package to the Azure app service, which we've provisioned. And so this is going to make the website, right? Alrighty, so what I want to do is I actually want to join the party. So at the moment, we have not got the app service running. So what I'm going to do is use Visual Code, and I am going to clone the repository up in Azure, and I'm going to clone that locally. So that's pulling that down. And now if I look at here, and I have a directory called Terraform, and in here is all the things that we need to deploy our system. So if I do a simple get status, you'll see here that everything is clean because I've essentially just pulled down the latest changes. So I am going to check out, what I can do is look at what branches there are. And you'll see here, there are a number of branches. So let's get that to the top. There's a number of branches here. So I'm interested in the Terraform one. So I'm going to check out the Terraform branch. And this is now going to track my local files here with what we have up in source control here. So I am using, excuse me, the same files. And what I can do is actually kick off a release because I just want to see this go. So let's create a release. We're going to deploy this to dev. And so we'll create that. And we have a release here that is going and is picking up the latest artifact, which was created, which was kicked off. You know, it did all the application side stuff that our app devs have been doing, did some tests, which is always good. And it basically copied our Terraform file, webapp.tf, up onto into the artifact. So if we come to our releases and our release here, this is now deploying our resources. So we've downloaded the artifact and we are now deploying using the Azure CLI. We're creating our storage account, and then as I mentioned before, we're going to have Powershell script to get the storage key. We're going to replace the tokens, and we're going to provision our site. So we're going to let this run for a while. While that's doing that, I want to show you how we can start doing some of the good things that the app service developers have been doing. We want to do that for our database. Up until now, we've had a database that we've provisioned manually. We've, been pushing things to it, connecting it to, the app service to it. And we want to automate that. We want to be able to spin up the database, tear it down as we've finished our testing, because there's no point having resources in Azure all the time and not being able to, and having to pay for them for ages. We don't want to do that. All right. So we're going to use Visual Code. I'll just find my directory. Yep, cool. So we're going to go to Terraform. And what we're going to do is open up our web app Terraform file here. And one of the things we actually want to do is, like I say, we want to embrace branching. And if we look at our repo, we have a number of branches. So we're currently on the Terraform branch. Well, what we want to do is actually create our own branch so that we're kind of isolated from other people. And so what we might do is create a branch called add database, right? So we've switched to our new branch. And what we can now do is actually make some changes to the Terraform file. We want to actually provision our database. So let's in fact do that. Here is some code I prepared earlier. And so again, what we're doing here is we are using, we're creating a resource, our SQL Server in Azure. We're basically using some variables. We're going to give it a name. And again, I'm going to make use of tokens so that I don't store any of this in source control. I can actually feed it in as part of our deployment process, having those variables in Azure DevOps. And here we have our actual database, which will sit inside our SQL Server up here. Alrighty, so if we now do status, we need to save this. You'll see here we have some changes. So let's just get that back up the top. So what this means is that Git has recognized that we've made a change to the web app Terraform file. So what we want to do is commit that, add that to our commit. We'll commit it. And that's now, added that, we've committed it. And now what we want to do is actually push this up to our remote repository. And so we're going to kick that off. And this has pushed it up. And now if we look at our branches up here, we have this one here, add database. And if we come and look at Terraform file, I've just updated it now. And lo and behold, down here, we have our new changes down here. And if we looked at one of the other branches, you know, the one that we originally were on and came in here, we don't have those changes. So that's all good. So let's now go and have a look at our release, and it succeeded. Let's just have a look at some of the things. So looking at logs, it successfully initialized. The plan was all good. It went through and had a look at, you know, the state of things and created the plan of how we would provision our resources. And then it actually went out and created the resources and deployed the actual code of our website. You notice here, you know, root, you know, all this developer stuff, whatever. So if we actually look in the Azure portal itself, somewhere down here is our new resource group, because this created a resource group. It created our app service plan, as I mentioned before, and it created our actual app service here. And the cool thing is, if we come out and have a look at the actual website itself, the app service itself, and to get there, I just clicked on this and grabbed the URL. I just told it to Azure to just give it a random number so that I know that I can always deploy this. And here we have our app service, our website, all created, configured by code and Azure DevOps. Alrighty, so what we now can do is part of our build. If we come to the build step and have a look at this, our build has a trigger that basically says anything that comes in on the Terraform branch, it does an automatic build, right? So enable continuous integration. So that means every time I push the Terraform, boom, we have the build kick off. Now, we're not on the Terraform branch. We're actually on the branch that we created, add database, this one here, and it's 19 changes ahead of the branch that we branched off, which was Terraform. So what we actually need to do is actually just for this first run, kick off a manual build, and that's okay because we're just still testing things out. So we'll actually tell our build to use the add database branch and we'll run that. And so what that's now doing is basically what we had before. It's going to go out, get our code from that particular branch, but it's going to, you know, basically we're hoping in terms of our website here, nothing changes. We're also hoping that in terms of the actual app service that's serving that website, that nothing changes. What we're hoping is that in the resource group here, we're going to have a couple more resources, right? That we're going to have a database and SQL Server. So we're going to let this run for a bit. And the real good stuff is in the release, because the release pipeline, if we look at that, it is also set to do continuous deployment. So basically, whenever anything is built on our pipeline, it's going to push it immediately into our dev system. So we're just going to wait a bit for this build to kick off and do its thing, and then we'll go and have a look at our release. And with the magic of recordings, here is the job finished. So if we come to our releases, we can now see that this release is kicked off. Let's go and have a look. It's initializing the job. And then it's going to go through our various steps. And just a reminder of what those steps are. We're going to check that we have our resources and everything. We're going to do our Terraform steps, but this time we're actually going to create a database. We're not going to do anything to the app service because Terraform recognizes that we have not made a change to our app service, so it just kind of skips it over, and it's going to deploy our changes. So again, we'll just let this bubble away, wait for it to do its thing, and then we'll come back and have a look. And oh no, we have an issue. We actually have an error. And I guess this is one of the things that I kind of like about Terraform is that it it's better at doing stuff than I am. You'll notice here that we have an app service resource named dev already declared at line 31. Okay, so let's have a look at our file. We have, I accidentally copied and pasted too much. Well, that's all good, you know, because what I can do is actually clean this up, do it properly, and save our file, check on the status of stuff. I always like to look at the status. It's kind of just making sure that everything is as I expected. I'm going to add my file. Cool. I'm going to commit. It's always important that you put something there that's meaningful. You see there, we've changed one file. There's 8 deletions because, yeah, I copied and pasted too much. So now we'll just push that up to our remote branch, and that's going to go away, do its thing, what have you. And if we check in our where is our branch? We'll go here. That's just been updated now. Here it is here, and I've made the change. So again, for now, we're just doing manual builds. We're not actually having this kick off automatically because we're still testing. Because once I'm happy that this works, I will then do a pull request and merge this code into the Terraform branch, which this job kicks off and builds from. So we'll again let this do its thing, and we will come back when it's finished. So that's now finished. So let's have a look at our release, and here we have a new release that's kicking off. It's queued. So we will now wait for it to do its thing, and hopefully I've got everything right. But you know what? If I haven't, that's the whole point of this exercise. I can make iterative changes, push them out, because the deployment pipeline, that's at least standard. The way I write code is never standard, which is why it's really good to have unit tests if you're as inconsistent at writing code as I am. And here we have it. things have deployed. So if we look here, it did take a fair amount of time to create our stuff, right? So it took about 2 odd minutes for for Terraform to spin things up. But that's just because it takes a wee while to create a server up in Azure. So it's not actually any fault of Terraform's that it took that long. It's more just that it takes a wee while to spin stuff up. Alrighty, so let's have a look and see what that's actually done for us. If we refresh our resource group, you'll notice here we now have a SQL Server, and I've called it Hamish on the end, only because I don't want to create. Well, I can't create a server with every server name. Now I could have chucked some random numbers in there, but I thought I would personalize it for this demo. Righty, let's actually connect to our database. So I'm going to use SQL Server Management Studio. Let's connect to it. And here we have our database, except of course it's empty. So what I could do is, start creating tables and everything on the database. But that's not what we want to do. We want to configure things using code, and to push those changes out, again, using a pipeline and having everything stored in source control. If I create everything here, and then, the whole point of using things like Terraform to spin up resources is we want to tear them down as well. We want this to be idempotent, where I spin it up, I throw some tests at it, and then I tear it down. Well, if I tear it down, I've lost all the changes that I just made if I do them manually. So the point of this is we need to get our database into source control. We need to get our processes into a DevOps mindset. So let's do that. So what we're going to do is we're actually going to use Visual Studio and SQL Server data tools to get our database into source control. So we're actually going to open up the solution. Now, the solution at the moment is purely all around application code, because that's what application people use. And so they have a whole heap of projects within the solution. And so we're going to join the party. We're going to bring the database into this. Now, it's pretty easy. And once you see kind of how easy it is to get to a database into source control, hopefully that will show you, or start you on that way. Now, there's a couple of different ways we can get our database into source control. This is just one of them. I've done many sessions at conferences on the various ways, and one of our sponsors, Redgate, have a brilliant way of getting it in. I'm going to use SSDT today, just to show you one way. So let's create a project within our solution. And the one we're going to use, as I mentioned, is SSDT. And you'll see here that you could actually use Redgate's SQL change automation. I'm not going to be doing that today. And so what we want to do is, again, house this where everything else is located. And we're the developers have their things there. And just because we're going to follow the convention that other people have, so parts database. And this is going to create kind of a peer solution for our database. Alrighty, so how do we get our database in? Well, because we actually have a development system here. If I zoom in. So this is our development system. So we're actually going to bring that into our solution, and it's pretty simple. We're going to import database. Now we could import, a DAC pack. We could actually bring in some SQL scripts, whatever, but I'm going to actually bring the database in itself. Here it is here. We'll connect to that. And it's really as simple for this demo anyway, of just bringing in that database, which will give us our definition. We'll finish. And what this has is it's the definition of basically everything within our database. So we have, our tables here. We have some stored procedures, right? And so again, this is representing it as code. And so, so again, this is a way that we can add our database into those pipelines. So you'll notice here that we have a whole heap of changes that we need to do. And you might notice here we've got some T-SQL-T because I actually like to write unit tests. And so we have a couple of unit tests here that we're going to add in that will run at some stage. And again, so we can actually put in a meaningful message, adding database to source control, and we'll commit all. Oh yeah, I always forget to save. So we're going to add that in, and you'll notice here we have an outgoing commit that we can do. What I can also do, let's say that others have done this, I can actually look at the status and it says that we're ahead by one commit. This is really cool because if I want to use the command line as I've done before, I can, or I can use utilities. You'll notice here, this is picked up that we have some changes. So yeah, I can just push this and that's going to push our changes up to source control. So now I can come along and actually look at source control. If I jump on the right branch, which I think was at database, and if I come in here, you'll notice that we now have added all the definition for our database into source control. So what that means is we can now actually start building our database and pushing it out so that when we have a look, out on our server, we're going to have a bit more than just nothing there. And again, we're not doing it manually, we're doing it as part of code. So what that means is we need to do a couple of things to our release pipeline, right? So we need to actually, at the moment, this is very application specific. So we want to add in a task to do our database stuff, which is what we're going to do now. So we're going to add in a build step for our database code. what we're going to do is fill it in with some values that are specific to building databases within using Visual Code. And some of these, you know, you don't have to worry about too much about what these are. They're well documented, and at worst, you know, you can collaborate with the application developers who are used to this a lot more than what we are. And in fact, that is one of the things I did, was I talked to people that, you know, live in Visual Studio all day, every day, and got them to help me. So what we're doing here is we are part of the thing that SQL Server Data Tools does is it builds a DAC pack, which is the model of our database, and it enables us to ship out that definition of our database all around where we need it. And so what we're doing here is we've built our solution here. We're now copying that to our staging directory because we need to ship that out. But we also need to publish our own artifact for our database artifact. So somewhere here, we'll grab this one. And again, we're just defining where things are at. So we actually want this in our own directory, and we'll call it database or something like that. And so we have an artifact for all of our app code, and we also have an artifact for our database code. So we'll just save that. But what we need to do is in our release pipeline, we actually want to actually deploy that out. So we're going to edit this. And for now, we will add it to our dev step while we're testing things out. And what we need is a DAC pack. So there's two types. We can use SQL Server Database Deploy. We're actually going to use the Azure one because we're using Azure, and we will do it before we do our application stuff, because my opinion is that if things are not working in the database, then we don't want to continue on. We want to remediate things. And so we'll just grab this. And the cool thing is, as I mentioned before, we have a whole heap of variables that we're going to use in our setup. And so our server, and variables are pretty easy to put in. And we're just going to fill this out with the various variables. Oh, I put it in the wrong place. And we will add in the database. And we're going to use that DAC pack file, as I mentioned, and this is in a very long-winded place. But again, this is picked up as part of the build, right? Okay, so that's essentially it for our release. So what I'm going to do is actually go back. So we've got our pipeline sorted. I'm actually going to go into this file here, which is the definition. And I've realized that I need some firewall settings for some people to connect. So this is a really cool thing. If I need additional definitions for my resources, I just update the Terraform template here, push it out, and then let it go. Now, I could actually do the push. So what we'll do is we will kick off a build just to show this working. So again, we'll choose our branch, which, as we know, has all of our changes. So if we come to source control, we have our database definition, which we did, and now that is kicking off. So again, I'm going to let this bubble away, and then we'll come and have a look at what it's done. The aim is that we have a whole heap of tables here that have been built from source control. And then if that works, what we'll then do is actually create a pull request from our add database branch and actually merge that into our Terraform branch so that every time that things are pushed, you know, we those changes will pick up what we have in the Terraform branch, because that's kind of our main branch for setting up our resources and everything. So we'll come back very soon and see what happens. Right, so our build has finished, and now we're just waiting for the release to come through. And as mentioned, the thing that we're really interested in is our database deployment as part of this. So yeah, again, we'll just let this bubble away and have a look very soon. And here we have our DACBack task, which is kicking off and deploying our changes. And here we have it deploying out, publishing. Okay, so now we can look at the DACBack, and as you can see here, it has published all the changes to our database. You notice here the Terraform steps actually went pretty quick, because there was essentially nothing for them to do because we have provisioned our resources. We weren't changing anything. And now if we look at our database, boom, we have all of our tables. We have all of our stored procedures that have been defined in code and are now deployed out. That means I can tear this environment down, right? And redeploy it from scratch now, and it will have our application code that runs, you know, the website. And, you know, that hasn't changed. And it also will now deploy the database. So because I know that that now works, what I could now do is actually do my pull request. So I would create the pull request on my branch. I could choose some people to review it. I myself, because this is my own tenant, what have you, subscription. And what I'm going to do is not do that. Right, so 47. So I'm going to create my pull request. I want to merge this into Terraform for now. Brief description. And I can choose some reviewers. In this case, it's just going to be me, so I'll just create it. And the cool thing is, it shows all the files and everything that I have changed, the number of updates, the commits that I've done, so that a reviewer can come along and actually review each of the changes that I've done, right? So as you can see here, the changes that we did was we added a database to our Terraform code, as well as we implemented adding in the database aspects of this, you know, our functions, stored procs and tables. Well, we've added all of that into source control, and it's a really cool way. We've kind of taken all the things from from DevOps. What we want to do now is actually put in some monitoring so that we can monitor our database, and our app service using things like BlazeMeter or hooking up Azure Monitor to our resources, so that when we make those changes, we can see that. So I'm just going to hit complete here, and I don't need my branch anymore in source control, so we're going to let that go for gold now. And there it's completed. So if I came to branches, you'll notice here that my add database branch is gone. My Terraform one has been updated, and look at this, there is already a build happening. So that kicked off because we have effectively updated our Terraform branch, and now it's just doing that, you know, the build. It'll do a release. The release is not going to do anything because we've already actually done it. But yeah, so I hope that has shown you some of the things that we can start extending, both continuous integration and continuous deployment. All righty. So again, hopefully that has given you some good insight into what we can do with introducing our database into a DevOps pipeline. So quick summary. Tooling can help you start to realize some of the benefits of DevOps. But you need to collaborate with other teams, which is ultimately going to dictate your success. You're the world's best DBA. They're the world's best application developers, but we can't have a silo between us. We can't point the finger at each other and go, your code makes our database, sorry, my database run slower. It's our database, and we need to collaborate. Learn some infrastructure as code techniques. I showed you Terraform today. There's a little bit of Azure CLI. There's a little bit of Azure Powershell. By the way, if you are using Azure RM, that's going to have updates stopped to it in December 2020. So look to move over to AZ Powershell or AZ Powershell. Embrace the cloud. It's a great place to try things out. One of the reasons why I got on the Azure platform was I was sick of trying to get infrastructure to build me stuff and wait for them to build me a server that took 2 weeks and took too long and wasn't the right server. So I learned how to provision things in the cloud, just tiny little environments. And because I don't want to pay lots of money, I learned how to decommission them and build them up straight away. Your job role is changing. You're more an engineer providing a platform for data than you are just an administrator making sure that queries and indexes are well tuned. Thank you so much for the coming along to my session. It is a live session. I had to do the recording because there were a few issues. If you follow me on Twitter, you're going to see a couple of the issues that I faced today. And I had to quickly pivot. And that's the whole point of DevOps. Making stuff go, you can do it in real life as well. And if you stick around, I believe that there is one of the mysterious QR codes that's going out. So thank you so much. Let's go with some questions.
Hey, Hamish, to start with, we have David has a question. How would this work with terabytes of data? Would you use something like SQL clone, or what is your recommendation?
Nice. The really cool thing is that with terabytes of data in our production system, we have to find a way of deploying out. So in my build, my functional test environment, they're not going to have terabytes of data. They're going to have 50 megs of representative data. And I will use tools like Redgate SQL, some of the Redgate products to introduce some of that referential data into source control. I can also use SSDT to bring in some of those, the referential data. I could even have a CSV. As we move along the deployment pipeline, we need to get to a point, and it could be pre-prod or staging environment that is terabytes of data. Now that's where SQL clone or SQL provision from Redgate could come in, because the great thing about those utilities, SQL provision, is it does data masking. So not only can I refresh my database really quickly, I can also mask the data. So that means I can let developers near it without worrying about GDPR or PII issues. So at some point, we do need to at least try it against those terabytes of data. But how we do that refresh or what have you, by all means, please script it. It shouldn't take 2 weeks to refresh our staging environment.
Thanks, Hamish. And we have another question from Yulia. Hope I pronounced that right. We don't have sprints right now. We deploy every week. We deploy the changes that are ready to be deployed. How do we handle branching? We don't want to merge before we are pretty confident that the change is ready to go into production. We are thinking to do the testing on feature branch and then merge into integration branch and do the UAT and then deploy to production. Is this the right approach?
You know what? Don't get hung up on what other people do. There is some really cool basic stuff that you need to do. And believe it, and I hope you know this, that you're doing it a right way. The fact that you are doing branching is really good. The fact that you're doing testing is great. You don't need to tie your deployments to sprints. I, in fact, like to deploy whenever I want. Let's say a feature is ready, deploy it out. And when the next feature comes along, deploy it out. Because what we want to do is architect our deployment pipeline so that the changes that we're doing is that the outage window is so small, and we might use blue-green deployments. The only thing I would say is your branches need to be short-lived. You know, once that feature's done, your branch should be merged into your integration environment branch, but at some point put it into your main trunk or branch so that we at least have it there so that other people will pick those changes up. Branches should not live for weeks, months, or years.
Thanks, Hamish. And then a final one by Sally. We have a DB pipeline using DACPack. The devs are set up as users in the database for dev QA. There is a step in the pipeline to grant connect to these devs as the final step of the script. Is there a way to set up DB users so that this step isn't necessary?
Yeah, there is. And I'm a bit worried. Are we almost out of time? Are we close?
We probably have a little bit of time. This is the last session in this room, so you're okay.
Oh, is it? Okay, yeah. No worries. Brilliant. So yeah, there's a whole heap of ways. We could have, I would generally script those users out. I'm hoping that these are users that are either managed, you're using managed identities in Azure, or they're Active Directory type users. And so we should, add them in to the database, as a step. I'm okay that it's a step. The reason why I'm okay is because then at least, it's hopefully picking up these users from some file or definition that we have somewhere. What I don't want to do is, having people, manually create them. Yeah, so I think that's fine. There's a couple of different other ways that would take it depends on your situation. But honestly, if that works at the moment, it's not the worst thing in the world. Yeah.
Great, thanks, Hamish. And that's it. And Alejandro is, and a few are looking for the QR code if you're done.
Alrighty. Yeah, I am pretty much done because, funnily enough, I've got to jump off soon and go and deploy some stuff to Azure. I'm showing a dev team how to incorporate monitoring, right? So it's great deploying resources, but we need to have monitoring to give us performance stats and to scrutinize how our system's going. And I also have to go turn my generator off. I was worried we were going to lose power today. But anyway, the QR code, I believe, will be shown very soon, if it's not already.